Hi everyone, my name is Dr. Richard Ordonez and I am an engineer and scientist at the Naval Information Warfare Center Pacific located in Pearl City, Hawaii. Today I'm going to talk to you all about nanomaterials. So nanomaterials are small materials that are defined as one dimension is less than 100 nanometers. So to give that some comparison, nanomaterials are actually about 100,000 times smaller than a single strand of hair. If you've seen some of our other videos, we talked a little bit about graphene, which is an atom-thick layer of carbon atoms stretched out in a honeycomb crystal lattice, and it was used for a variety of different things like in optical sensors and devices that reduce heat. So another type of nanomaterial is quantum dots, which we use here at the Naval Information Warfare Center for optical devices. So to show you some quantum dots, I have prepared a glass slide here, and you can see that these little bubbles right here, there's little droplets of a bunch of quantum dots. So quantum dots are defined as little nanoparticles in which the size and the shape of the quantum dot actually just determines its absorption and emission properties. So I'm going to shine here in this middle one here, and you can see that it turns orange. This one over here on the right turns green, and this one over here on the left turns red. So as I mentioned, the size and the shape of the nanoparticles actually determines its emission and absorption properties. Here, the quantum dots in the middle actually have a size of approximately maybe like 6 to 7 nanometers. The one on the right maybe might have a size of about 4 to 5 nanometers. And the one over here on the left, the red ones, are actually much larger than those other ones. So you've seen quantum dots before. They're not new materials. Like every time you walk into Costco, and you walk by those very expensive TVs at the front door, those are quantum dot LED TVs. So folks have learned that you could use quantum dots and LEDs because you have the ability to carefully control the type of color that these quantum dots emit. So back in the day, we went from a few colors now up to 16 million different types of colors that can be used to make better displays and optical devices. So to give you a little bit more of how these quantum dots are unique, I'm going to show you here a spectroscopy setup that we have here. And optical spectroscopy is defined as a study that actually shows us how matter interacts with electromagnetic radiation. So here is an optical spectroscopy setup that consists of a laser. You see here in the back with this little cord kind of coming up here. The laser actually goes through a optical path. It actually hits a mirror and then goes down into the subjective and then shines that, in this case, 532 nanometer green light onto these quantum dots. And if I were as a scientist and I wanted to explore the chemical and physical nature of these quantum dots, I could use a spectroscopy setup like this. So for example, just for show right now, I want to know what color is this quantum dot with respect to its wavelength. So now I'm going to come over here, and you can see on this display here, I have plotted the intensity of the quantum dot that I have over there and the wavelength on the bottom, on the x-axis, and I can determine that that particular quantum dot is actually emitting around 610 nanometers, which is typically around the orange color. So now I can know that, hey, this quantum dot that was made with an orange color to it. So with that in mind, talk to you a little bit about quantum dots, which are nanomaterials and other nanomaterials like graphene. And if you would like to learn more, you can contact any of us at the Naval Information Warfare Center Pacific. Thank you.